Hello everyone, welcome back to Python programming course. Throughout the previous lectures, we learned about different data structures like list, tuples, sets, and dictionaries, and we have also written many Python programs related to these data structures. In today's lecture, we are going to cover another very important topic in Python, that is functions. Imagine you are working on a large software project with thousands of lines of code. If you keep writing the same code again and again, your program becomes difficult to read, difficult to maintain, and difficult to debug. Professional programmers don't write the same code repeatedly. Instead, they use one of the most powerful concepts in programming, which is functions. In today's lecture, we will understand what functions are, why we need them, and how they help us write clean, reusable, and professional code. So, a function is a reusable block of code that performs a specific task. Let's understand this definition. A function is simply a group of statements that work together to perform one specific job. Instead of writing the same code many times, we write it once inside a function. Whenever we need that task again, we simply call the function. Think of it as creating a machine for a specific purpose. Once the machine is built, you can use it as many times you want. For example, I have a television remote. I have a TV remote. And when I press volume plus button, volume increases. If I again press volume button, it again increases. Every time we press the volume button, we don't manually increase the speaker volume ourselves. The TV already has a predefined function that performs this task. We simply press the button and the same operation happens every time. Programming functions work exactly the same way. Now, why do we need functions? Imagine I am printing the name of different students. I am printing welcome Rahul, welcome Aman, welcome Priya, and so many more. Say I am printing this 100 times. I am printing welcome name 100 times with different name. Now tomorrow if I want to change welcome to Python programming, if I want to change this to welcome to Python programming, Rahul. If I want to change this at 100 places, this will waste time and increase the chances of mistakes. Now suppose the message changes, we only modify the function once. For that we will create one function which prints welcome 100 times. Now if I want to change welcome to Python programming, I will have to change only this welcome statement, this statement only. Every place where the function is used automatically gets updated. This is the biggest advantage of functions. Now we will quickly look at the advantages of function. Why is it so important in programming? The very first advantage of function is code reusability. We write the code once and use it again and again. This saves both time and effort. The second advantage is reduce code duplication. Instead of writing the same code repeatedly, we write it only once. Third is easy to read. Programs become neatly divided into smaller sections instead of one huge program. So we get small understandable parts. Fourth is easy to debug. Suppose your program has 2000 lines. If everything is written together, finding an error becomes difficult. But if the program is divided into functions, we know exactly where to look. Next is easy to maintain. Whenever requirements change, we update only one function and instead of modifying the entire program. So now we understand what functions are and why they are so important. It's time to learn how to create our own functions in Python. In the next part, we will learn the def keyword with the function syntax and how to define a function and how to call it. In the previous section, we learned what functions are and why every programmer uses them. We also saw that Python provides many built-in functions like print, input and length. But what if Python doesn't have a function for a task we want to perform? That's where user-defined functions come in. User-defined functions are functions that we create ourselves. So what are user-defined functions? A user-defined function is a function created by the programmer to perform a specific task. Think of Python as a toolbox. It already gives us many ready-made tools, but sometimes we need a special tool that doesn't exist. In that situation, we create our own tool, and that custom tool is user-defined function. Now we will look at the syntax of the user-defined function. The user-defined functions start with a def keyword, and after def keyword, we write our function name. And then we pass a colon, and after that we start writing our statements. Statement 1, 2, 3 and depends what the number of statements depend on how like which type of function we are going to write. The def keyword tells Python that we are defining a new function. Just like variables have names, functions also have names. We should choose meaningful name as calculate salary, display menu. And then we have this parenthesis. The parentheses are required at every part of every function. For now they are empty. Later we will learn how to pass information in this parenthesis. The colon tells the Python that function body is about to begin. If we look at the visual representation of functions, firstly the program starts. After starting a program, the next is function is created. After function is created, we wait for function to be called. Then function is called. After function is called, code executed. Code is executed. And after that we return back. Notice something important. When we create a function, Python does not execute it immediately. It only stores the function in memory. The function runs only when we call it. Now, what is the difference between function definition, and function call. What is the difference between these two statements? Function definition creates function, and function call executes the function. Function definition is written only once, and function call can be used many times. Function definition uses def keyword, while function call uses function name. Think of a recipe book. Writing a recipe is like defining the function. Actually, cooking the dish is like calling the function. A recipe doesn't cook itself. Similarly, a function doesn't execute until it is called. Now we have learned how to define a function and how to call it. But right now our functions cannot receive any information. Every time they run, they do the same task. In the next section we will learn parameters and arguments. Now we know how to define and call functions, but our functions have one limitation. They always perform the same task. Imagine a calculator that can only add 10 plus 20 every time you press the button. Would that be useful? Of course not. We want our functions to work with different values every time we use them. That's exactly why Python provides parameters and arguments. Now why do we need parameters? Say I have a function which print welcome Rahul. This function always welcomes Rahul. What if tomorrow we want to welcome Aman, Priya or Simran? We would have to create separate functions for every person. That's not practical. Instead of creating many functions, we create one function that accepts different names. So parameter is a variable written inside the function function definition that receives data. Think of parameter as an empty box. When someone calls the function, Python puts the value inside the box. After parameters, we have arguments. Now an argument is the actual value passed to a function when it is called. If a parameter is an empty box, then the argument is the item placed in the box. Imagine you are owning a pizza shop. You have a pizza shop. Customers order different pizzas every day. Now we don't build a new pizza oven for every customer. You use the same process but with different orders. The order details are like arguments, and the place where the order is received is like the parameter. The primary differences between parameters and arguments are: A parameter is written in function definition, while an argument is passed during every function call. Parameter is like a placeholder, while an argument is the actual value stored in that place. Parameter receives data and an argument sends data. Now we have different type of arguments. The very first type of argument is positional argument. Positional arguments are matched based on their position. Matched based on their position. Say I have a function, and in the function I have name and age, and when I call this function, the name becomes Rahul and age is 20. The first value goes to the first parameter and the second value goes to the second parameter. After positional arguments, we have keyword arguments. Keyword arguments specify the parameter name when calling the function. For example, I say name equals to Rahul and age equals to 20. Python knows exactly where each value belongs because we mentioned the parameter names. After that, we have default arguments. Sometimes a function has a value that usually stays the same. Instead of typing it every time, we can assign a default value. Assign a default value. Say I put country to India. If no country is provided, Python automatically uses the default value, which is India. In the function, we can use multiple parameters. We can have a one parameter, 2, 3 or as many as we want. Now, what is the benefit of parameters? The first is reusability. One function can work with many different values. One function can work with many different values. After reusability, we have flexibility. Flexibility means different inputs produce different outputs. Cleaner programs. Instead of creating many similar functions, we create one flexible function. So now we understand how functions can receive information using parameters and arguments. But many functions don't just perform a task, they also give something back. For example, a calculator doesn't just add numbers, it returns the result. In the next section, we will learn about the return statement. So far, we have learned how to create functions and how to pass data to them using parameters and arguments. But here's an important caution. After a function finishes its works, how does it send the result back? Imagine you use a calculator to add two numbers. The calculator doesn't perform the calculation, it shows you the answer. In Python, we use the return statement to send the result back from a function. A return statement is used to send a value back from a function to the place where it was called. Think of a function as a worker. You give the worker a task, the worker completes the task, then the worker hands the completed work back to you. That final step, giving the result back, is called returning. So the flow of program looks like, firstly we will call the function call, then we take input, then process, then return result, and then program continues. Now why do we need return? Imagine we want to calculate student marks, salary, profit, tax, average. If the function only prints the answer, we cannot easily use that result in another calculation. With return, we can save the result and use it later. Differences between print and return is the print statement displays output, whereas the return statement sends value back. Print statement cannot be reused, whereas return statement can be stored in a variable and then can be reused. Print statement is used mainly for displaying. Whereas the return statement is mainly for calculations. Beginners often think that print and return are the same. They are not. Print simply displays something on the screen and return sends the value back so that the program can use it later. things works like we have a function. See, we have a function and I use a print statement. This print statement will be shown on screen. Whereas if I have a function and I'm using a return statement, this return statement will store the value in a variable. And then with the use of that variable we can do further calculations. Now when should we use return? We use return when we need the result later, we want to perform more calculations, we want to store output in a variable, or we want another function to use the result. And we use print when we only want to display information and no further calculations is allowed. If I talk about benefits of return, then the very first benefit of return is reusable results. The returned value can be used anywhere. We have clean programs. Functions become independent and reusable. Better program design. And we have easier testing. So in the final theory section of this lecture, we will learn about variable scope, which is one of the most common sources of confusion for beginners. We will understand the difference between local variables and global variables. We have learned how to create functions, pass information using parameters and return values. But here's an important question. Can every variable be used everywhere in a Python program? The answer is no. Some variables are available only inside a function while others can be used throughout the entire program. This concept is called variable scope. Now what is variable scope? Variable scope is a region of a program where a variable can be accessed. Think of scope as a variable's permission area. Every variable has a place where it is allowed to exit. Outside the area, Python cannot recognize it. Say Rahul belongs to class A. Rahul belongs to classroom A. If the teacher is in classroom A calls Rahul's name, he responds. But if in another classroom any teacher calls Rahul's name, he may not even be there. Variables behave similarly. Some belong only to one function. There are two types of variable scope. First is local variable and second is global variable. Firstly, we will understand what is local variable. A local variable is created inside a function and can only be used inside that function. Locals means limited to one place. Once the function finishes, the local variable disappears. Every time a function runs, Python creates local variables. When the function ends, those variables are removed from the memory. After local variable, we have global variables. A global variable is created outside all functions and can be accessed throughout the program. A global variable belongs to the entire program. Every function can read it. Say, every classroom can read the notice board. It isn't limited to one room. A global variable works the similar way. As we humans have our own lifespan, variables also have a lifetime. Now, why do we need local variables? Imagine every function used the same variable names. Program would become confusing. Example, login function, payment function, search function. If all of them shared every variable name, one function could accidentally change another function's data. Local variables help keep each function independent. And in case of global variables, sometimes information needs to be shared. For example, company name, tax rate, website name. These values are needed in many parts of the program. Instead of creating them repeatedly, we store them one as a global variables. Every function, say I'm creating a banking system, the every function needs the bank's name. So it makes sense to keep it as global variable. So now we have successfully completed the theory section of lecture 8. We have learned what functions are, how to define and call functions, parameters and arguments, difference between print and return, local and global variables. In the next session, we will switch to Jupyter Notebook and practice everything we have learned so far. Theory session, we learned what functions are and why they are one of the most important concepts in programming. Now it's time to create our own functions in Python. We will start with simple examples and gradually move towards more practical programs. So open your Jupyter Notebook, create a new notebook and let's begin. In the very first program in this particular lecture, what we are going to do, we are going to create our first function. For function creation, firstly, we write def, then we will write the name of the function, say my function's name is greet, then colon, and then we will write our statement, which is print welcome to Python. And after that, we will call our function. We will write greet, then print. So it prints welcome to Python. Now let's break this down. Def tells Python that we are creating a function. Greet is the function name. Parenthesis means this function takes no input because I haven't passed any value in the parenthesis. Then colon starts the function body and the greet calls the function. The thing we have to understand here is creating a function or defining a function doesn't execute it. The function only runs when we call it. Now I have created this function and the function is stored in my memory. Now, if I want to again call this function, I just simply have to write greet. And the number of times write greet, the function will be executed. One function can be called as many times as we want. This is the biggest advantage of the functions. We write the code once and we can use it again and again. Now what we will do, we will try to make multiple functions. My first function say is greet, which prints hello. And in my second function, I want to print goodbye. So I will name this function def goodbye. And this function will print goodbye. Print goodbye. Here you can see there is no output because I have just defined the function. I yet need to call it. For calling, I will write greet and then I haven't called this function. Now I'm calling this function in this cell. So now this will give me an output, which is hello and goodbye. A single program can contain multiple functions, each performing a different task. Now, if I write goodbye first and then I write greet, then what will happen? Which statement will be executed first? So obviously goodbye will be printed first and hello will be printed after. The functions execute in order they are called, not in the order which they are defined. Now what we will do, we will try to call a function inside another function. Say I have a function called def, which says greet and print welcome. Now what will I do? I will create another function named start, and in the start function I will call my previous function which is greet. Now I will call greet on here only, and then I will write a statement for the second function, which is say I write let's begin Python. Now, if I print greet, if I call greet, it will print welcome. But if I print start, if I try to call start function, the start function will automatically call the greet function. So in the output, we will have welcome and let's begin with Python, both of them. So here the thing which we understand is functions can call other functions. This is very common in real world software development. Now we will look at the function execution flow. Say I create a function first. In the first in this I will print inside first function. Then I will print program starts. And then we will call first. And then we will write another statement program. And if I print this, so here you can see Python execute code from top to bottom. When it reaches first, it jumps into the function, executes it, and then comes back to continue the program. So we have successfully created and called our first user-defined functions. We also learned that functions only execute when they are called, that they can be reused multiple times, and that one function can even call another function. In real-world applications, function needs to work with different data every time they are called. That's where parameters and arguments becomes useful. So let's understand them with practical examples. Firstly, I will create a function with one parameter. Say my function name is greet, and in the parenthesis, I will pass my parameter, which is say name, and I will print hello name. So this is my function, which prints hello in front of the name which is passed. Now I will run this. I will run this function. So now the function will be only executed when we call it. So let's call the function. Say I want to greet Rahul. So in the parenthesis, while calling, I will write Rahul. So it prints hello Rahul. If I write hello Aman, so it will print hello Aman. So the name is the parameter. Rahul and Aman are arguments. The same functions work for different names. Say I create another function. Say I want this function to add two numbers. So I will name this function add. Now we are adding two numbers. So I will add two. So I will insert two parameters.
My first parameter is A and second is B. And I want to print the sum of two numbers. I want to print sum equals to A plus B. So this was my addition function. Now I will call this function. Now inside the parenthesis, I will pass two arguments. Say I want to add 10 and 20. This will print 30, which is absolutely true. If I try to add any different numbers, it will work fine. So the function receives two values and performs addition. This was the work of this function. Now in the second function, in the next function, we will create a function which will show student details. Say I created a function named student and I want to print the student's name as student's age. I want to print name, which is name, and I want to print age, which is age, age. So now I defined the function. Now we will call the function. For that, I will write student. Say student's name is Rahul and age is 21. So it will print name Rahul, age 21. If I say student, name is Aman, so it will give me an error because our student function create takes two arguments, but I have passed only one. So here I have to pass another value, which is age, say 28. So it prints name Aman, age 28. Here we can take three arguments also. If I say I introduce another parameter called marks and I say print marks, and I run this, and here I have to pass the marks also. Say Aman Rahul got 98, so it print marks as well. So we can pass as many parameters as we want. Now we will take example of different types of arguments that we learned. So the very first argument is positional argument. For that, let's create another function. I will create an info function. Then in the info function, I will pass the name, comma, city. And I can print the name as well as city. And say, I will call this function here only info Rahul and city is Delhi. So it prints name Rahul, city Delhi. So the first argument goes to the first parameter and the second argument goes to the second parameter. With so the arguments represents their respective positions. That's why they are called positional arguments. After positional arguments, we have keyword arguments. For keyword arguments, I will use the same function. Say I write this function and while calling, I write info. But firstly, I will write here, firstly, I will write city. So if I write city equals to Delhi and I write name equals to Aman. So Python understands that this Delhi is for the city argument and the name is for the name Aman is for the name argument. So it automatically puts them in their value and it prints name Aman city Delhi. Since we specified the parameter names, the order doesn't matter. After that, we have default argument. Say create another function named def country and I write name here. I pass my first parameter which is name, and after that I pass my second parameter which is nation. But I will give it a default value which is say India, and then I will print it. I want to print name, comma, lives in nation. Okay, don't forget the column. Say I will run this function. Say passed Aman, comma, and the city nation name is USA. So it will print Aman lives in USA. But what if I don't pass the nation name and I pass Rahul? So it will print country. CUNTR. It prints Rahul lives in India. So whenever we don't pass any value, it prints Rahul's in India. Why? Because I have already defined the default value to nation. So in case if I don't pass the value of the nation as an argument, so Python automatically takes the default value. Now let's solve a problem. So in this problem, what we are going to do, we are supposed to create a function which calculates the area of rectangle. For that, we will define a function named area, and the rectangle has two dimensions, which is length and width. And we will print the area. Print area is, so the area of rectangle is equals to length multiplied by its width. Say I pass 10 as length as 50 as width. So the area is 500. Now in the next function, what we are supposed to do, we are supposed to check whether a number is even or odd. We already know the logic of even and odd. If the remainder of the number with 2 is 0, then the number is even, else it is odd. So we have to use the if else statement inside the function. So I created a function named def check, and in the argument I will take uh, sorry we will take num as parameter. So now we will write up a statement which is if num remainder 2 is equals to 0, then print num is even, else print num is odd. Say I want to check 21. Have you done this code? So 21 is the odd number, which is absolutely correct. If I say again check and I will pass the even number, say 20, so 20 is even, which is also correct. Now moving to the next question. Now we are going to create a function to print the multiplication table of a given number. So I create a function named table, and I will pass one parameter which is num again. I pass n as my parameter. Now we will use the for loop inside the function. For I in range, I want to print the table up to 10. Range 0 to 10. Sorry, 11, because 11 is excluded. The stopping condition is excluded in the range function. Then I will print num We will use X mark for multiplication sign. I, here is not now, here is N, is equals to N star I. And after we will print the table. Say I want to print a table of 5. So it prints table of 5 from 0 to 10. So now we have learned how to make functions flexible using parameters and arguments. Instead of writing separate functions for different inputs, you can now create one reusable function that works with many different values. So in the next practical session, we will learn about the return statement, and you will see how functions can send values back to the program. So now we will learn how to use return statement through practical example and understand why return statement is more powerful than print. So let's create a function. We will create a function. Say I'm creating an add addition function. I will add a comma b, and now we won't print this. We will use return, and after return we will write what we want to do with these two parameters. So here I want to add these parameters, so I will write a plus b. Now, how do we call the function? For that, we will create a variable called result. And what does this result will do? This result will add 10 and 20. And if I print this result, this will give me the value, which is 30. 10 plus 20 equals to 30. So what is happening is the return a plus b sends the answer back. The returned value is stored in the variable result, and then we print that particular value. Now we will see the difference between the print statement and the return statement. Firstly, I will create a function. In this function, we will use print using print, and this will print 10 multiplied by 20. And then we will use def using return, and this will return 10 multiplied by 20. Now we will call both of these functions. Firstly, I will call using print. For that, I will write using print. Simply, we will write using print. And for value, we will write value equals to using return, and we will print the value. Print value. Now both of them gives 200, but the second function returns the value, which allows us to reuse it later. So that's the primary difference between print and return statement. If we use the return statement, we can reuse it later, which is not the case with the print statement. Let's look at some another examples. We will create a function to print the square of a number. So I will name it square n, and return statement I will write return n star n. Now I will create a variable, say answer, which is equals to square 5. We will print answer, which is 5 multiplied by 5 equals to 25. Now let's look at another example, which is largest of two numbers. So we will create a function. We will pass two parameters, and the function will return the largest number. Say def largest, function a, two parameters a and b. Now we will start. If a is greater than b, then return a. If else return B. If I print largest 50, 80, so it prints 80, which is largest among both of them. And if I print largest 100, 80, so it will print 100, which is the largest among both. Now in one particular function, we will try to return multiple values. So what I'm going to do, I'm going to create a function and I'm going to return values like sum, product, division, and subtraction. Say create a function named def calculation. I will take two parameters a and b, and now we will define our statements. First is sum value, or we say add, which is equals to a plus b. Then we have div, which is equals to a divided by b. Then we have multiplication, which is a star b, and then we have subtraction, which is equals to a minus b. Now we will return add, comma div, comma multiplication, comma subtraction. Now let's say d a comma d comma m comma s is equals to calculation 50 comma 20, and if I try to print here, I want to print only the sum of both, so I will say a, so it will print sum, which is 50 plus 20. If I want to print division, I will print d, which is 50 divided by 20, which is 2.5. For multiplication, I will write m, which is 1000, and for subtraction, I will write s, which is 30. So Python allows a function to return more than one value. Now next, we will create a function to calculate the area of a circle. Say, I will create a function def area, and in this we will pass r, which is our radius, and it will return area. So the area of a circle is pi r square. So 3.14 multiplied by r multiplied by r. And now I will print say area whose radius is 7, which is 153.86. So now we can write functions that don't just display results but return values for further use. This is a key skill in Python and is used in almost every real world application. In the final session of this lecture, we will combine everything we have learned today to build a mini projects and understand local and global variables through code. In this final practical session, we will combine all the concepts which we have learned so far, and we will try to create smaller projects which will enhance our knowledge regarding what we have learned so far, and we will also learn about local variables and global variables in this particular session. So the very first thing which we are going to create is a calculator using functions. So the calculator will perform basic calculations like addition, subtraction, multiplication, and division only. So let's create our first function. I will create separate functions for each task. For addition, I will create an add function. We'll pass two parameters a and b, and it will return a plus b. After that, we have subtraction. We will create another function, def sub a comma b, which will return a minus b. Then we have multiplication, def multiply a comma b, it will return a starving. Then we have division. Def division A comma B return A divided by B. Now we have all the return statements with us. We will now take two numbers num1 and num2 input from the user. Num1 equals to int input, enter the number, and in a similar way we will take n2 as input. After that we will start printing our statements. Firstly we will print addition, print addition, then comma we will call our function which is add num1 comma num2, and in the similar way we will call each operation. So we have checked, entered the number 5, the addition is 10. Now we will call each function in the similar way. Print addition, then we have print subtraction, subtraction, multiplication, and division. Subtract, multiply, divide. The first number is 50, the second number is say 2. So it prints addition 52, subtraction 48, multiplication 100, and division 25. So each function here is a separate function, and function returns the results. The second project which we are going to make is the second mini project, I would say, is student result system, which will assign grade to students based on their marks. The function name is student result system. Firstly, we will create our function which is calculate grade. Argument is in the parameters I will pass marks. Then if marks are greater than equals to 90, then return A. If marks greater than equal to 75, return B. Else if marks greater than equals to 50, then return C grade. Else return fail. Now we will take the name and marks as input. Of marks. Now we will call our function and print the following statement. We will print the following statement. Print student name skill issue, grade equals to marks. So now let's enter the name. Say name is Rahul and marks are 55. So the student, it prints student name Rahul, marks 55 and grade C. Moving to the moving to the next and the final project of the day, that is BMI calculator. We know about body mass index, which is calculated as weight divided by the square of height. So now, firstly, I will write the project name, which is BMI calculator. Say create a function def calculate BMI, and I will pass the weight and height as parameters. Now we will return weight divided by the square of height. So the weight is equals to, we will take values input from the user. We will take float inputs because the weight and height can be in decimal value. Input and the height. So now we have our inputs. Now we will call the functions BMI equals to calculate BMI, weight and height. Now we will print it. Print BMI is equals to. So this round function is used to round off a value to particular decimal places. Say I want to round off the BMI calculated BM2 up to two decimal places, so I will put 2 after comma. So now it will round off the calculated BMI to two decimal places. And now what we are going to do, we are going to create a if statement loop, which will print the category like underweight, normal, overweight based on the BMI. If I say if the BMI is less than 18.5, then print category underweight. Elif, the BMI is less than 25, then print category normal. Elif, the BMI is less than 30, then print category overweight. Else, print category obese. So shift press enter. Firstly, we will enter the weight. Say weight is 65.5 and our height is 156 centimeter. So BMI is 0.0, category is underweight. I will run it again then. 50, say 56. Let's print experimentation. Here the BMI is also updated. So this was all for today. Now we know what functions are, how to define and call functions. We know about parameters and arguments. We know about the return statement, the difference between print and return, local and global variables. So in our next ninth lecture of Python programming course, we will explore modules and packages in Python. And you will learn how to organize code in multiple files using Python built-in modules like math and render.